Hey there, guys. Start section 1.4. I'm actually going to have you start it off looking on pages 41 and 42 of your textbook to fill in this section here that I've highlighted for you. Make sure you fill in the blanks up here and that you find the labels for these boxes. And then there you need to define degree of a term, degree of a polynomial, and then what we call something that only has one term, two terms, three terms, or four more terms. And then there's also defining standard form down here. This is all stuff that you've gone over before in different classes, so it should be familiar to you. We're going to go ahead and use that information to answer these questions here. So there are four things they're asking us to do: find the degree of this polynomial, find the leading coefficient, classify it by its number of terms, and then write it in standard form. Usually I find doing part D first to be the most helpful thing, so I'm just going to go ahead and do that. So to get it in standard form, I want to put it in order. So since this term here has the highest degree, I'm going to go ahead and write that one first. So that'd be negative 3x squared, and then the positive 8x. So make sure the signs follow each term. And then since the degree is the highest one, so that would be a second degree, which we would call a quadratic. And then classify the number of terms. That has two terms, so that is a binomial. And then, oops, that was C. I'm all over the place here. And then B is leading coefficient, so once it's in order, first number. So I'm just going to abbreviate that LC, and that's equal to negative 3. So just kind of go through that stuff, nothing crazy. Let's see if this helps a little bit, zoom in. So degree of the polynomial, so this one has no variables, so that's a degree of 0, which means that it is a constant, which makes sense because negative 17 does not change, so it is constant. The leading coefficient, well, there's only one thing going on here, so the leading coefficient is negative 17, which technically really isn't a coefficient because coefficients are numbers in front of variables. Yeah. There's only one term here, so this is a monomial. And then D, you're writing in standard form. Well, not much to do there. Only negative 17. And then C, again, I'm going to start with part D here just because it's all out of order. So negative x to the 6th plus 4x squared plus 2x minus 6. And then part A, that is the degree, so that is a 6th degree, that is a highest exponent. We don't really have a special name that's used a lot for 6th degrees. Leading coefficient, so that would be the first number now that it's in order, so that would be negative 1. So leading coefficient is equal to negative 1. And then C is the number of terms, so that's 4 terms, so that is a polynomial. Poly meaning many, so it has many terms. All right, so that's just kind of taking note of what we're looking at. It's always a good idea to kind of understand the problem, the expression or the equation you're looking at, like what type it has, because a lot of times, certain types of equations have certain methods of solving them. If we go to solving a quadratic, we're looking at factoring or a quadratic formula or something like that. You just solve a linear equation. It's really something very simple to do using our inverse operations. Solving a higher order equation has different tactics. So kind of just making note of what type of equation or expression you're looking at. You're like, oh, okay, I know this is going to be the graph of a parabola, since it's quadratic, or things like that. So just being able to identify that, it's good. Adding, subtracting polynomials, again, something you guys have done a bunch. Here's a little bit to fill in, and then a couple quick examples to do. So nothing that should be too difficult for you. Look on page 43 if you need any help there. And then moving on to multiplying polynomials, again, something you've done a bunch of. So when you multiply the terms of a polynomial, we are going to be using the distributive property, which should not be too surprising. And you always want to write the product in its simplest and standard form. So if you're going to think about it horizontally, so just straight up using the distributive property, so that 3x needs to be distributed here, here, and here, and then the 2 needs to be distributed here, here, and here. So if we distribute the 3x, so of course 3x times x cubed would be 3x to the 4th, and then 3x times negative 4x squared would be negative 12x cubed, and then 3x times 7 would be positive 21x. And then positive 2 times x cubed would be positive 2x cubed. Positive 2 times negative 4x squared would be negative 8x squared. And positive 2 times positive 7 would be positive 14. And so here's our simplifying, putting things in standard form. So looks like I have some cubes I need to combine. Looks like that's it. Everything else is singles. So that would be 3x to the 4th. Negative 12 plus 2 is negative 10x cubes. And I have negative 8x squared, it's positive 21x's. All right, so there's our product. Easy peasy. And just a different method. Same problem, different way of doing it. And this is the way I know I teach my Algebra 2 students to do this. Same, it's the same problem, 3x plus 2 times x cubed minus 4x squared plus 7. So if you're just worried about organizing things, forgetting a term, we had to do 6 arcs there. This is just a different way of setting up. So setting up a 3x2 box to do that. Only thing I would do different here, I would write 3x, and then I would put plus 2, and then it has the x cubed minus 4x squared, and then I just like to emphasize the signs on those other terms. So just emphasis. So then what I'm going to do here is just just kind of like lattice multiplication. So I'm going to take 3x times x cubed. So that'd be 3x to the 4th, and then just doing each row. So 3x times negative 4x squared. And then 3x times 7, so then positive 21. So again, I really do like to emphasize that, put the sign there on all of them except for the first one. And then 2 times x cubed, so that's positive 2x cubed. 2 times negative 4, so we negative 8, and x squared, and then 2 times 7, which would be positive 14. Let's go, like before, go looking for like terms. So I got those cubes, that's not a cube. I'm just writing everything out in standard form. So, oops. 3x to the 4th, and then minus 10x cubes, minus 8x squared, plus 21x's, plus 14. So that's the box method. Obviously, they both work. Just kind of do what feels good for you. I tend to do the box method on my own thing. All right, I want you guys to try these 2 problems, and I'll throw those up as questions on the Ed puzzle so that you can check your answers. and see if you need help there. But I doubt you will. Squaring a binomial. So what we're talking about here when we say squaring a binomial is 4x minus 1 squared. This is really a big thing. It's probably one of the things I'm most annoyed by as a math teacher, is that people doing this problem incorrectly. So you must remember to write the binomial twice. Which means that you can't just drop the exponent in. This is not okay. That's super bad math. So you need to remember to write 4x minus 1, 4x minus 1. That means to multiply something by itself. And then we go through and do the FOIO, the distribution. So 4x times 4x being 16x squared. Then we get negative 4x, and then negative 4x, and then positive 1 there. And then combining those like terms, we get 16x squared, and then minus 8x's, and plus 1. So that should be your binomial cubed there. And then multiplying conjugates, this is something you definitely would recognize from when we talked about factoring, and we did talk about this in Algebra 2. I know it's something we had to leave out. We talked about it in a couple different times when we were working with radicals. Actually, we just talked about it in the 1.3 lesson, multiply by conjugates with the radicals. We also talked about it when we were doing stuff with I in Algebra 2. So when you multiply conjugates, so remember that's when the sign is different, but everything else is the same. Hopefully, maybe you can recognize that from our factoring times. That's where we get our difference of squares. So there's a shortcut, and I'll show you that real quick, or afterwards. But if you just do the distribution, you get 2x times 2x, which is 4x squared, and then 2x times negative 7 would be negative 14x, and then 7 times 2x would be positive 14x, and then 7 times negative 7 would be negative 49. So the final result is 4x squared, and then minus 49, since the middle terms cancel. But it's just one of those things, if you happen to recognize it, oh, hey, those are conjugates, that you can say, well, I know those middle terms are going to cancel, so I can just ignore them. And so all I have to worry about is the 2x times the 2x, and then the 7 times the 7 with the negative sign, since one's positive, one's negative, and you can just go straight to there. You can ignore the 2x times 7 and then 2x times negative 7. So it's just one of those things, if you recognize it for what it is, you can do it faster. Just like anything, you don't have to work through problems. It's kind of like when we talked about like the shortcut AC method versus the long AC method. You can only do it sometimes, but when you knew to do it, it made things a lot faster. So you can only take that shortcut sometimes. This shortcut here sometimes if the two binomials are conjugates of each other. But if you know to do it, then you can save yourself some time. So. And wrapping up here. If you have multiple variables, it really doesn't change anything. Same rules apply, like it says. 6a minus b times 2a plus 3b. Just, distribution. So 6a times 2a would be 12a squared. And then 6a times 3b would be positive 18. And then AB, since that's alphabetical. Negative b times 2a would be negative 2ab. So again, I want you to stick alphabetically there. If you didn't, I'll show you what goes wrong. So if you're like, oh, b's first, I'm going to put b's first. And the last one here, negative b times 3b would be negative 3b squared. And so looking at combined like terms, like obviously a squared is a squared and b squared is b squared. But looking at these two, you might not recognize that they are actually like terms if you don't write them alphabetically. So that's the reason we do that. AB. So 18AB minus 2AB is 16ABs. 12a squared plus minus 3b squared. So kind of standard form for a problem like this. There's not really a truly set way to do this, but a lot of times we just see that, we'll start with the first variable, we'll end with the other variable, and then in the middle will be where they're mixed. So you can also do like the first variable squared, then the second variable squared, then start doing the mixture ones after that. But this is a pretty common way to see this, where first variable squared, end with the second variable squared, and then the middle is the mixture ones. So. And then last problem, so I'm going to throw this into a table or grid. So I'm going to do a 2x3 grid. And then on the side I'm going to have 3x and then minus 1, and on the top I'm going to have 2x plus 7y minus 9. And 3x times 2x is 6x squared. 3x times 7y is positive 21xy, go alphabetical. 3x times negative 9 would be negative 27x. Negative 1 times 2x is negative 2x. Negative 1 times 7y, negative 7y. Negative 1 times negative 9 is positive 9. Any like terms? Looks like I have some x's. So, trying to get this into standard form. Again, I see that x squared, so I'm going to start there. This one's a little weird because it has like xy's and it just have x's and y's. Again, I guess I'm going to go xy next, just because there's more variables there. And then negative 2 and negative 27 will give me negative 29 x's, and then I have the negative 7 y's, and the plus 9. So it's not really, again, a particular standard form when you have mixtures of variables, but that would be, starting with the highest exponent, ending with no exponents or no variables. That would be it. There is your assignment, a little different than what was written there, so be careful about that. Hopefully you found that pretty easy. Thanks, guys.